We are going to talk about the Field Service Lightning Optimizer. The Field Lightning Optimizer feature let us reach an efficient schedule. And first of all, let me just introduce Field Service Lightning. So Field Service Lightning is a Salesforce technical field service management software. It means that we are managing technicians. For example, Field Service Lightning is suitable for customers having mobile workers, for example, technician performing installation, repairs, or maintenance on client site. So the basic business scenario is a customer writes a ticket and call a center agent, and then the center agent will create a work order in the system. And when we have multiple work orders, a dispatcher user will dispatch all these work orders to a field technician. At the end, technician will receive all the details about the appointments with the customer with his mobile app. So this is the typical business scenario. I want to talk about a common computer science problem, which is the traveling salesman problem. So, which is defined by asking this question. Given a list of cities and distances between each pair of cities, what is the shortest possible route that visits each city and returns to the origin city? So answering to this question is naturally we'll try to assess all the combination. So we'll have a 360 combination. It's kind of a brute force approach. And we will try to find the optimal route for this problem. Modern algorithm suggests using the heuristic and approximation approach, and we are away 2 or 3% from the optimal solution by using this algorithm, and we will have a solution with a reasonable amount of time. Another classic computer science problem, which is the VRP, vehicle routing problem, defined by asking this question. What is the optimal set of routes for a fleet of vehicles to traverse in order to deliver to a given set of customers? So VRP is a kind of NTSP, which means we have multiple traveling salesmen, and we need to find the most optimal route. So the objective of VRP is to find the, so these are the variant of VRP. So what are the objectives? So objective of VRP is to minimize the costs, minimize the travel time, and minimize the number of vehicles needed to go to serve our customers. And we have multiple variants of VRP. For example, when we have a time constraint, we can talk about vehicle routing problem with time window. So we can deliver to the customer at 1 a.m., so that's why we add a time constraint. So these objectives are common to Salesforce Field Service Lightning implementation. And the main objective is to minimize travel time, minimize overtime costs, and maximize efficiency. So we can say that FSL is a flexible VRP variant because what is optimal to a customer is not necessarily optimal for another customer. That's why Salesforce FSL offer a way to configure what we call a scheduling policy. A scheduling policy is a set of work rules and service objectives. Work rules are a kind of requirement and hard yes, no qualifiers. For example, we have a rule match skills. So if you are eligible to perform a job, you need to have that skill. And service objectives are more like nice to have or desirable goals, helping us to define what is the most optimal resource for the job. So we are having this kind of, these are the types of work rules available in Field Service Lightning. Match Boolean, we can have the ability to match with a custom field or a custom formula if you have a specific business case. Technically, these are work rule is a custom object, and these are the record types. So we can't create new record types because the optimization engine considers only these record types. We can only configure these rules adding the appropriate parameters. Concerning the service objective, the FSL offer us these objectives. So we can give a weight to each objective in order to help us achieve a desirable goal. So service objectives are kind of nice to have, are optional, not like work rules that we need to satisfy the rules. So for example here, I was able to configure FSL with this service objective, which is match skill level. So I gave 100% of scoring formula on skill level. It means that when we have multiple technician candidates for a work order, we will consider the most experienced technician, or the technician having the best skill level, who will be performing that work role. So, for example, this is the dispatcher console. I've created 4 technicians. Every technician have a skill level. I created a skill which is French Touch Gaming, and the level is 10, 30, 40, and 20 for each technician. So when I try to see the scoring for each technician based on my policy, I can find that this technician, Jane Austen, have 100 as a score because he have the better skill level. Now we are going to talk about limits of the optimizer. We are having maximum service appointment optimized per 24 hours, which are 50,000. Other considerable limits. So this one is important to consider. The optimization requests take longer with SLR, street level routing. So by default, distance between 2 work orders addresses is calculated with a straight line route, which means that we are calculating the distance directly. But with the SLR, we are considering the real route with the street and road, considering the road and street. We also have a setting for optimization runtime, so we can configure it as low, medium, or high. If you want an optimized, the most optimized most optimized schedule will require a high execution time. So I've created a simple, basic example. So we're having one technician, which is a tourist, trying to visit all the places in Paris. So I've created work orders and put all the addresses here, and then try to schedule myself all the work orders like this. And after running the optimizer engine, where I'm getting less travel time like this, and I only have 2 days instead of 3 without optimization. So I will try to demo. So in my scenario, I've created a lot of work orders. I'm having 2 types of work type. One for expert, which is complicated installation, and one is a simple installation. We have 2 expert resources and 2 normal technicians, which having the basic skill of installing. Uh, I tried scheduling these work orders. It will take time. Sorry. After that, I have 2 remaining appointments. The system was unable to schedule these 2 appointments because the 2 experts are really busy. After that, I ran the optimization engine. Just before running the optimization engine, we are having 35 hours here assigned to my resources and an average travel time which is 29 minutes. So when I create an optimization request, it is an asynchronous call to an optimization cloud server. It means that the optimization it's not within the org. So after the optimization ran, I'm having 38 hours, 30 minutes of utilization. I'm having an average of 15 minutes travel time, which means that it was really efficient, more efficient to schedule all the work orders for my technician. So other use case, we can use the optimizer for a specific use case. For one technician, for example, if you have scheduling overlaps, if you have 2 appointments at the same time, we can only just run the optimization engine to that specific resource, and then we can also configure how to behave after rescheduling the appointments. So these are other use cases like group nearby appointments. It means that we are just getting all the other appointments nearby. Reshuffle appointments to schedule high priority. It means that we can have prioritize some appointments rather than others, so we can reshuffle appointments. And the other are optimize a single resource schedule. We can also run the optimization engine for only one resource. So for this one, for example, I have one resource with a lot of, I run the fixed overlap for only one technician, and it got fixed with the optimization engine. So to reach the efficient schedule with FSL Optimizer, we need to define our own policies. For emergency, the normal policy, for quality policy or quantity policy, it means that we can define as soon as possible or as a service objective. We have also to define our workloads and service objective for each policy. And if we are happy with our optimization engine, we can schedule optimization job to run weekly or in a daily basis. Thank you. Questions?
Does it have to, the optimizer, does it have to work with like users? Obviously you've got your field service technicians. Could it work with another resource like sort of custom objects, so like a room, for example? So you've got a series of events and you've got to try and work out, like this agenda, for example, you've got a whole series of talks, different times, different facilities, set that up to run an optimizer to schedule something which is not based on human resource.
I believe it's not. Maybe it's possible with workarounds because to have a resource, you need to have a license for that. So if you buy a license for something other than a user, so it will cost you money, but technically it's feasible.
So technically, if you've got like 50 rooms to manage, you would need 50 licenses.
Yeah.
Okay.
Yeah, it's possible.
Yes. Is field service functionalities for the map, regarding the map, is it based on Google Map or
No, it's not based on Google Map. It's by default, it's a straight line route. It means that between point A and point B, we consider the distance between A and B with a straight line routing. And we can define the, sorry for that, the SLR, I believe, street level routing option. Yeah, this one. Street level routing is, I don't know if it is based on Google Map or not, but they will consider the route using the normal roads. So the calculation will be more accurate for the distances.
Anyways, you need to have a map somewhere in order to calculate. So you have.
No, the engine, you don't see the map. You run to the engine, and the engine with geolocation properties will be able to calculate the distance. So I don't know the engine itself is using Google Map or not, but yeah. That's okay. Thank you.